Welcome back to ME 760, Engineering Analysis 1. So we will continue with the same business that we started last time, which is solving the differential equation using the Bar series method. And in order to be able to solve the differential equation, ordinary differential equation with variable coefficients, for example, with using the Bauer series method, you have to have your P of x, Q of x, and R of x in the equation. For example, let's say that this is second order equation. You have to have those functions and are defined as analytic function. And we define analytic function as what? As a function that does not have any singularity at, let's say, a point like x naught. And you can represent those functions as a Bauer series. So this is the definition of analytic function. So last time we wrote the Legendre polynomial y double prime plus b of x y prime plus q of x y equal to 0. And we showed that this function, it has, this is the general form. So the Legendre polynomial, it was 1 minus x squared y 2 minus 2x y1 plus L plus 1y equal to 0. So this is the general form of the second order differential equation, and this is the Legendre equation. And we stated that in order to transform it to the general form, we will divide by 1 minus x squared. So this is 2x divided by 1 minus x squared multiplied by y prime plus L multiplied by L plus 1 divided by 1 minus x squared multiplied by y equal to 0. Last time we said that x equal to 0 is what point? Okay, we can make it y double prime. Y double prime. What do you say? X equals 0 is ordinary point. So this is ordinary point. And we will see in a minute that we can find or seek a solution based on Bauer series method around x equal to what? X equal to 0. Then we stated that x equal to plus or minus 1 are singular points, but are they essential singular point or ordinary singular point? Regular singular point. Why? Because if you multiply this term by 1 minus x, if you multiply it by 1 minus x, what? Yeah, if you multiply it by 1 minus x, for example, this would be 1 minus x multiplied by 1 plus x. If you multiply this, if the singular point is 1 minus is x equal to 1, for example, so if you multiply by 1 minus x here, you will eliminate the singular point. Okay, guys? Now, let's examine the other point. For example, is x equal to infinity? Is it what type of point? Is it a regular? Is it what? What type? What type of point? Huh? Essential. We'll examine it here. So we'll put z equal to 1 over x. Y prime of x will be just dy by dx, and it is be given as dy by dz multiplied by dz by dx, and this will be just 1 over x squared dy by dz. There is a minus sign in front here, and you can write it as negative z squared dy by dz. if you get y double prime, I'm not going to derive it, but I will write it here as z cube multiplied by 2 dy by dz plus z d2y by dz square. So if you take this one and substitute into the equation here, Legendre equation, let's call it 1. So substitute in equation 1, you will end up with equation in the form z square multiplied by z square minus 1 d2y by dz square plus 2 z cube dy by dz plus l minus 1 y equal to 0. So now, what's p? Now b of z instead of b of x. B of z will be what? 2z divided by what? This is z square minus 1. And what is q of z? Would be L multiplied by L minus 1. Is it L minus 1? L plus 1 actually. So L plus 1 divided by z square minus 1. And there is z square in front. So this one at z equal to 0, which is x equal to z equal to 0 corresponding to x equal to infinity, and this is what we are looking for. What's at x equal to infinity? At z equal to 0, this is equal to what? 0 divided by minus 1 is what? Is 0. So p of 0 equal to 0. So this is what?
Wouldn't p of 0 also be divided by z squared times z squared minus 1?
Which one?
P of z.
P of z is 2z cubed divided by z square multiplied by z square minus 1. Z square cancel z cube, and you will have z in the upstairs. Excuse me. What about the second one at z equal to 0? Z equal to 0, q of 0 blows up. Yes? But if we multiply by z square, if we multiply by z square the function q of z, this will give us at z equal to 0, this will give us what?
0.
Why? When you multiply this will give you L plus 1 divided by z square minus 1. So when z equal to 0, this will give you L multiplied by L plus 1. And this is what? Finite. Yes? So you eliminated the singularity by just multiplying by what? By z square. So this is not an essential singularity. This is what singularity? A regular singularity. A regular singularity. So this function here is what? So z equals 0, meaning x equal to infinity, is what point now? We examine this case, z equal to 0, it's our ordinary point. and Q is not ordinary, it's a singular, but it's not essential singularity, it's a regular singularity. So what's Z equal to 0 now is what point? Yeah, so it's a regular what? Is a regular singular point. What? So it's not ordinary. It's why it's not ordinary? Because the condition was what? You have to have P and Q. They are not singular, and you have to have P and Q can be represented by a power series. But only P is what is ordinary, but Q is not ordinary. But Q can be transformed to analytic function if you multiply by Z squared. So this is not essential singularity. This is just what singularity? The regular singularity. So now, why we are doing this? We are doing this to test if the functions P and Q can be expanded. If the function P and Q can be expanded in a power series, if they are analytic function, they can be expanded in a power series. If they are not analytic, for example, at x equal to x naught, they can be made analytic by being multiplied by what? By some function. And if this is the case, still we can expand P of x and Q of x in a power series, and we can have a solution for this equation, which is y of x expanded as a power series. If this is essential, P of x and Q of x are essential at x naught, they are essential, x naught is essential singularity. This means that I cannot expand P of x or Q of x as a power series, and I cannot find the solution, power series solution for the differential equation. So we will take an example here to show you the series solution for some differential equation. But before, I will give you just a theorem here, and then we will take the solution, the examples. So the theory stated that if you have x equal to x naught, and this is an ordinary point, then every solution for the equation y double prime plus P of x y prime plus Q of x y equal to R of x, let's call this a star. Every solution where P of x, Q of x, and R of x all are analytic. Analytic means that they do not have singularity at x naught. So if at x naught is an ordinary point, and every solution for this where B, Q, and R are analytic at, all of them are analytic at x naught, will be a solution. This solution will be also, so the solution will be also analytic at x naught. So what we are saying here, and this solution can be expanded as an x minus x naught to the power of n from 0 to infinity. So what we are saying here, we are saying that if at x naught is an ordinary point, then what happened is, excuse me, if x naught is an ordinary point, what happened is x naught is ordinary point. P of x, Q of x, R of x are analytic. What does mean are analytic? They do not have singularity at this point, and they can be expanded in power series format. So the solution for this equation will be in the form of y equal to a power series. So this solution will be also analytic. So it does not have a singularity at x equal to x naught, and the power series, you can expand it here as a power series. Okay, guys? So this is just, and this power series the power series solution, this power series solution will converge, the power series solution will converge for x minus x naught less than r, where r we took last time, r is the radius of what? Radius of convergence for the series. And we defined the radius of convergence of the series last time. Okay, guys? So let's take an example here. So our example is y double prime of x plus y equal to 0. So what's the solution for this one? Here, b of x is equal to r of x is equal to 0, and q is equal to what? 1. We knew that this solution is what? Y is equal to a. Come on, guys. What's the solution for this one? This is simple harmonic motion, y double prime equal to minus y. Yes? Which is y double prime equal to minus omega square y. And this is simple harmonic motion. So what's the solution for a simple harmonic motion? Yes, a cosine omega x plus b cosine omega x, and omega is 1, omega square is 1, so omega 1. So this will be a cosine x, b sine what? X. So this is, we knew that this is the solution from the normal way of solving this types of differential equation. Now we will assume that our solution is just y of x equal to the summation from n equal to 0 to infinity of an x to the power of n. So we will do exactly the same like last time. What's y1? N equals 0 to infinity n x to the power of n. What's y double prime? N equals 0 to infinity. What? So this is n multiplied by n minus 1 an xn minus 2. Then we will substitute as we did before. So when you will substitute, you will obtain the following summation from n equal to, here n equal to 0 and here n equal to 0, but actually you will not start until n equal to what? 2. So we can put here n equal to what? 1, and here n equal to what? 2, because 0 is 0, just 0. So this will give you summation from n equal to 2 to n multiplied by n minus 1 multiplied by an xn minus 2 plus what's y? Summation from n equals 0 to infinity an x to the power of n equal to 0. We can change this to make it n minus 2 equal to what? S. Okay? And we can make this also S. So this will be what? So n minus 2 equal to S. So S will start from 0 to infinity. And this will be what? N will be what? S plus 2 multiplied by S plus 1 multiplied by an as x to the power of S plus as x to the power of S equal to 0. Yes, guys? So this will lead to what? This will lead to, this is S plus 2. Nobody informed me here to change this, guys, because n minus 2 equal to S, so this is S plus 2. So AS plus 2 equal to minus AS divided by S plus 1 multiplied by S plus 2, and this is the recurrence relation that will, give us the formula. So let's start. S equal to 0, A naught, yes? S equal to 0, A naught, and S equal to 1. A1 is equal to what? So if this is S equal to not S equal to 0, let's make it like this. S equal to 0, this is A0 divided by what? 0 plus 1 is 1, 0 plus 2 is 2, so this is 2, and this will be what? A2, yes? Yes?
How about the AN? Why is it AS only?
Which one?
When you converted it to S.
Okay, this is a separate summation.
Ah, okay, sorry.
So this summation here, I will substitute with S minus 2 equal to, N minus 2 equal to S. But
It doesn't
here it does not matter. You put S, you put M, you put whatever, it does not matter. Okay? So you cannot use N minus 2 equal to S here, and then you said, I will convert this to the same.
Sorry.
Otherwise you change.
I was just thinking.
Yeah. Otherwise you change the. Did you understand?
Yeah.
Okay. So A2 equal to what? Minus A naught over 2. What's A4? 4. S equal to what? 2. So this will be minus A2 divided by 4 multiplied by what? 4 multiplied by 3. But what's A2? Minus A naught over 2. So this will be A naught over the factorial of what? Of 4. And what will be A6? Minus A4 divided by 6 multiplied by 5. If you substitute with A4, this will give you A naught divided by what? 6 factorial and so on. So let's take the other component, A3. A3 will be, S will be what? 1. So, and 1 plus 1 is what? 2, and 1 plus 2 is what? 3. So this will give you 3 multiplied by 2. So this is what? Minus A1 divided by factorial of 3. What's A5? A1 over factorial of 5. What's A6 or A7? We already got A6 here. A7 is what? Minus A1 over factorial of 7. So now, go back and substitute into your formula. What's your formula for the solution? Y of x equal to the summation n equal to 0 to infinity an multiplied by x to the power of n, and this will give us, okay, let's take the odd or even, let's say take the even numbers. So the even number is what? Start with what? 2, yes, but we have we have what? A naught multiplied by 1 minus x squared over what? Over 2 plus x to the power of 4 over what? 4 minus x to the power of 6 over 6, and so on, plus A1 multiplied by what? If this is 1, this will be 1, so A1 multiplied by x minus x3 divided by factorial of 3 plus x to the power of 5 divided by factorial of 5 minus x to the power of 7 factorial of 7 and so on. So what's this?
That's a cosine.
Yeah, so this is what? Cosine x. And what's this? I showed to you last time. Yes? So this will give us what? A cosine x plus a1 sine x, which is the same solution we got from the analytic method. Okay guys, let's take a little bit more tougher example. This is a tough example here. This is just a simple one. So you knew what's the methodology now of finding a series solution?
Right, y as a series solution.
So you will first check check if you want to get the solution of y of x equal to a n x to the power of n. You want to see your function p, q, r, are they analytic or not? And then if they are analytic, at what point they are analytic, then you will figure out the power solution at this point, the analytic point that you are talking about, x naught, for example. Here is x naught is what? 0. Yes? So we took our x naught is 0 because p of x and r of x are what? 0. They are not functions. And q of x is just 1, constant. So we can pick up any point. We pick up what? X equal to 0. Okay, guys? And we find the solution around the x equal to what? 0. And this solution, it has two what? Two linearly independent parts. One that's function only of what? Even function of x. And the other one is what? Odd function of x. If you divide y1, this is y1 of x. And this is y2 of x. If you divide y1 by y2, you will never get a constant. So what does it mean? One is not a constant multiplication of the other, so what does it mean? They are linearly independent. And this is, yes, cosine and sine are linearly independent functions. They are not produced from one another by a constant, multiplying one by the other by a constant. Did you understand? So here is how we solve it here. Let's take the Legendre polynomial here, and this is 1 minus x squared multiplied by y double prime minus 2xy prime plus L multiplied by L minus 1 y equal to 0. We will call this equation number 1. Then this equation is analytic at what point? Equal to 0. It is analytic at x equal to 0. We just studied this.
Should you have L times L plus 1? Like
Yeah, I'm sorry. Thank you for reminding me. So it is analytic at x equal to what? 0. What's p of x? Minus 2x divided by y x squared. What's q of x? L plus 1 y minus x squared. So we can find the solution at x equal to what? 0. And this solution will converge in x minus x0 should be less than what? Radius of conversion. Where do you think the radius of convergence here for those equations? I expect the radius of convergence, this equation P and Q, they have a singularity at what? Or x equal to what? 1. So unless x goes to what? 1. So this is 1 and this is minus 1. This is x equals 0. So you have a solution inside this circle here. And if you are if you come closer to 1 and minus 1, what will happen?
It doesn't converge.
It does not converge the power series solution. So this is what we will try to do right now. So we will examine the solution y of x equal to the summation from n equal to 0 to infinity of an x2 power of what? N. Substituting 1. So what's so if you substitute, this will be 1 minus x squared. Y double prime from here is what? Summation from n equal to 2, because you start with 2, and this will be n minus 1 an xn minus 2 minus 2x multiplied by n equal to what? 1 n an xn minus 1 plus l plus 1 multiplied by what? Summation of an x to the power of n equal to 0. Okay guys, here is a trick. It's not like the last time. Last time we have all x's, they have the same power. So we have x to the power of s, x to the power of s, x to the power of s. So all what we will do is what? We take x to the power of s as a common factor, and we just added the coefficients in front of x to the power of s, and we got a relation that those coefficients should equal to 0. Here we have what? X to the power of n minus 1, but when you multiply it by this, you will have x to the power of n minus 2, sorry, and this will eliminate the x to the power of minus 2, so it will be x to the power of n, and here you will have x to the power of what? N again, because this n minus 1 multiplied by 1 is what? X to the power of n, and here is x to the power of n. So I have to equate, get the coefficients of what? Of the similar x's. So x1, coefficients of the x1 equal to 0. Coefficient of x2 equal to what? 0. Coefficients of x3 equal to what? 0, and so on. So let's study this. What's x0? What's the coefficients of x0? x0 will come from where?
Your first term.
If you substitute, if you substitute here, you will notice that 0 will come when this multiplied by this will give you what? Xn. But you start with n equal to what? So you will not have x0 here. So an xn minus 2 multiplied by 1 is what? Is this multiplied by x to the power of n minus 2 and n equal to 2. This will give you what? A0. So n equal to what here? 2. Yes? So this is 2 multiplied by 2 minus what? 1 is what? Is 1 A2. So this will give you the x0. Here, this will give you x0. This will give you x to the power of 0? No? Because this is x multiplied by x to the power of n minus 1 is x to the power of n. Yes? And n goes from 1, so you do not have any x0. But this will give you x to the power of 0 when n equal to what? So this will give you what? Yes? And this will give us A2 equal to L multiplied by L plus 1 multiplied by A0 divided by 2. So what's x1? Which one will give me x1? So the first term will not give me x1. Will give me x1 actually if n equal to what? 3. Yes? Yes, guys? Will give me x1 when n equal to what? 3. So 3 multiplied by 2 is what? 6. And this is A3. Yes? And this will give me x to the power of what? Of n. And n equal to 1 will give me x to the power of 1. So this is what? 2 multiplied by 1 is 1, and this is A what? A1 plus L multiplied by L plus 1 multiplied by N equal to 1. So this will give you what? A1 equal to 0. Yes, guys? And then you will do x3, x4, x5, x7, up to x to the power of what? M. Okay? How to figure x to the power of m?
That negative come into play anywhere?
Which one?
You have the first term minus the second term.
This one? This one?
In the original equation up top.
This should be minus 2a. Yeah, minus 2a1. Which one you said minus?
No, that's what I was saying.
Okay. Thank you. So how we will do the x to the power of m? So the first term, can you tell me what's the first term now? The first term up in the blackboard here. So this will be what? We will multiply this multiplied by 1, then minus x squared multiplied by this. So can somebody tell me now? This will be summation from n equal to 2, n minus 1, an x n minus 2 minus summation n equal to 2, and then this will give us n minus 1 x to the power of n minus n minus what? X n minus 2 multiplied by x squared. This is x to the power of n plus 2 multiplied by n from n equal to 1 to infinity x to the power of what? To the power of n.
Shouldn't that be a minus?
Plus which one should be a minus?
Yeah, x, or, yeah, that one there.
Minus. Plus L plus 1 multiplied by the summation of what? an x to the power of n equal to 0. Okay, guys? So if I make this n minus 2 equal to m, so this will give me the summation from m equal to what? 0 to infinity, and this will be m equal to what? So this is m plus 2. Yes? What I will put here, I will choose what? From here I will choose what? n minus 2 equal to m. So m will be equal to what? m plus 2 equal to what? n. So n minus 2 is m, and n will be m plus what? M plus 2 multiplied by n minus 1 is m plus what? 1 multiplied by x to the power of m plus or minus. Here I will choose what? I will choose n equal to m. So this will be m minus 1 x to the power of m, because I do not have to change n here, yes? So I will call n equal to m. So this is m minus 1 x to the power of m. M started from what? 2. But does it make any difference if I make m start from 0?
Well, you'll...
I do not have anything, because if m starts from 0, the first term is what? 0. And the second term is what? 0. And I will start from what? M equal 2. So I did not make anything. Yes?
On your first term, you left out a sub n, which will be a sub m minus, or plus 2. Yeah.
A sub m plus 2. M plus 2, m plus 1, a sub m plus 2.
And again on the second term.
And second term will be a sub m Yes, guys? X to the power of m. And then, what's this one? Minus 2, summation from, I will change also n to be m. And does make any difference if I start from 1, from 0? Nope. So this is m, am, x to the power of m, plus l, multiplied by l plus 1, m equal to 0 to infinity, am, x to the power of m equal to 0. Now, let's collect terms here. So, when you collect the mth term, what you will see? Coefficients of x to the power of m should equal to 0. What are the coefficients for x to the power of m? M plus 2 multiplied by m plus 1, m plus 2 minus m minus 1, am minus 2, am plus l plus 1, am equal to 0. So if you rearrange and get am plus 2, you'll notice that it is minus m square minus m minus l square minus l divided by m plus 2, m plus 1, am, which can be written as am plus 2 equal to minus l minus m multiplied by l plus m plus 1 divided by m plus 1, m plus 2, am. This is the recurrence relation for the Legendre equation. So let's check this recurrence relation. So it's a little bit tricky. It's not easy like before when we solve it for exponential function or cosine and sine. We collected the terms from x to the same power. So you will notice that a for m even will be proportional to a naught. Look here. L is what? Is a constant. Yes? It might be 2.4, 2.6, 3.7, anything. It might be also integer. And we will see the special case when L is equal to integer. But A naught, yes, will produce what? A naught plus 2, so it's A2. Then when you substitute with A2, you will get A what? A4. Substitute with A4, you will get A what? 6. So the even m will be proportional to what? A naught. And odd m will be proportional to what? A1. Yes? So we'll have two categories. When you do the expansion here, you will have two categories. So let's look at even coefficients. The even coefficient A2 will be just negative L multiplied by L plus 1 divided by factorial of 2. A naught, A4 will be just equal to L minus 2 multiplied by L multiplied by L plus 1 multiplied by L plus 3, all divided by factorial of 4, A naught. Let's look now for the odd coefficients. So the odd coefficients will be just what? A3, and if you substitute it, you will get L minus 1 multiplied by L plus 2, all divided by factorial of 3 multiplied by A1, and A5 will be just L minus 3 multiplied by L plus 4 divided by factorial 5, but here L minus 3 multiplied by L minus 1 by L plus 2 by L minus 4, actually plus 4, A1. Okay, guys? So what's the most general solution now? Our general solution will be two parts. One, you will have the even coefficients, and the other one you will have what? The odd coefficients. So here is the one with the even coefficients. You will have A naught 1 minus L plus 1 over factorial of 2 multiplied by x squared plus L minus 2 multiplied by L multiplied by L plus 1 multiplied by L plus 3, all multiplied by x to the power of thirds.
Would that be x at 4?
To the power of 4, sorry, I'm sorry. X to the power of 4, all will be divided by factorial of 4. So this is the first term. The second term is A1, and this will have what? We'll have the first term x minus L plus 2 x cube over factorial of 3 plus L minus 3 L minus 1 L plus 2 L plus 4 x to the power of 5 divided by factorial of 5, and so on. So this will be what function? y1 of x, y2 of x. Are they linearly dependent or linearly independent? Why?
Divide the first by the second.
And even exponent, yes, function, and an odd exponent function, you will never transform them to each other by just multiplying by a constant. Yes? If you divide this by this, you will never get a correlation just based on a constant. Yes, guys? So this is the solution now for the Legendre equation. Now, L here, we knew that L is what? Any number. Yes, any number. But what if L is just an integer? So the relation that I just erased, which is AM plus 2 negative L minus M multiplied by L plus M plus 1 divided by M plus 1 multiplied by M plus 2. So 4L is integer. What will happen? What will happen when M equal to this integer? Let's assume L equal to 7. So what will happen to when M equal to 7? 0. Yes? So 0. So A7 will be m equal to 7. So A7 here, and you will have A9 is equal to what? 0. And A11, A13, A15, you will have the odd number polynomial here truncated after L equal to M. So it will truncate. But this one will do what? Will continue for infinity and will do what? Will converge in the region where x minus x naught less than r, which is negative 1 to plus 1. Yes? What if L is, instead of 7, is 6? So you will have what? A6, and A8 will be what? 0, and A10, A12. So you will truncate this one, and you will get a polynomial of degree L. Yes? And the other one will do what? Will expand until infinity, but it will converge in the region of convergence around 0. Yes, guys? So next time I will talk about this property, and this is just, we can write the truncated polynomial here, P of x as P sub L of x. We will write it as P sub L of x, and this is what we call the Legendre polynomial. If you study Legendre polynomial. So next time I will just give you what we mean by the Legendre polynomial and distribution and everything. Okay, guys, do you have any question so far? Anything difficult? Anything easy? Everything is okay? Okay.